Alright, we are up and running. Hello everyone. My name is Sil. Today we are returning to Princess Dungeon Smasher. I think I'm going to do a little bit of cleanup today, get stuff in the game client a little bit nicer looking. I've closed all of the regions here, but probably not as much time today, probably around a half hour. We're going to try and add some entities, and the entities are basically going to be the base class for our player, any objects that move, and those are going to have to be saved into the level file as well as loaded. But once they're loaded, they're going to change values, move around, that kind of thing. So let's go ahead and get started here. I do want to clean up just a little bit. What was it exactly? There was a couple things I wanted to clean up in this class here. Sorry, it's been a little bit since I've worked with this. I haven't come back to this since I streamed last. We're going to go ahead and get rid of this there. Alright, well, for now I'm just going to leave it actually. We're going to go ahead and make a new class here called Entities. So we go do add class. Or sorry, it's just going to be entity. And the entity is going to have a public. Do we want to have a public? Let's make it private because we want to make accessors because we want to control whether or not people can move the entities. So it's going to have a public point, and the point comes from system.drawing. Frick. Point. Right click on that. System.drawing. It's going to have position, and we're going to hold a last position as well. Public point position. We're going to make an accessor here. Get return position. For now, we are simply going to only have a get here. We need to get rid of that semicolon. We need to do the same thing for the last position here. There we are. We also need to have a public. Hold on. You know what I might want to do? I think. No, this will work. Okay, so this entity class is going to be the class that we have as the base item, or the parent class, for all of the in-game entities, or like instances, essentially, right? We're going to make another class called entity type, which will be saved to... Well, The problem is that we need an entity type with a position saved to the file. So we need something that's serializable, that's able to be saved, but I don't want to limit this entity class to a serializable object because I want to be able to do anything I normally do with game objects with this entity class, and I don't want to have all of the children classes have to be serializable as well. Let me think through this just a little bit here. We might just go a little bit unorthodox here. What we'll do is we'll make a class, and we'll call it a level entity. Well, a savable entity. I don't think that's how you spell savable. How about we do entity serializable? And what we can do is this gives us a good idea that this is an entity, but it's also serializable, so it's not a normal entity. And what we can do is we can make some functions in the entity class in order to get a serializable entity to save to a file if we want to save something that's already existing as an entity. And then we can also take an entity serializable and turn it into a real entity. I think that'll work well. So we also need an entity type enum. Actually, we're going to put that Yeah, let's go ahead and put that in entity. Let's go public enum entity type. Where did I put the other one actually? We have tile type. So, no, I think I'm gonna move it. I'm gonna move it over to the serializable class here, just to keep things all the same. Let's go ahead and open up our content folder here and look at our sprites, our entity tile sheet to remember what type of entities we have here. I have not demoed the game, the original games. I've actually made this game a couple times. I've made it once in XNA. I've made it actually twice in XNA. I made it again in XNA, made it nicer. I then made it in Game Maker for a while, and then I made it in MonoDevelop. What is it called? Monogame, I think, is what is the name of the framework, which tries to emulate XNA. And I feel like I've almost tried to make it once in OpenTK at one point, but this is the first real try I've done in OpenTK. So what we have here, we have a box. We have a box with unlit light and lit light. These are the same entity. We have a gem, which are just little pickups. We have a door that needs to be opened. Where is... Oh, here we are. So this is the open door. I think I might change that sprite. It doesn't look very recognizable. And then we have this, basically the ones with the little boxes with the lights you have to put on all of the tile spaces that are all of these entities in order for this door to open. We have the exit, which I really do want to change the key, which kind of needs to be changed as well. The heart wasn't ever actually used in any of the versions. We have doors for all of 4 different colors here. We have gray, blue, green, brown, and those doors are opened by keys, which at the moment I don't think they really have any type of color coordination. And then we have these little switch blocks, as I like to call them, or switch entities, which will switch, or what do you call it? They'll rotate, they'll cycle through a list of different tile types of the tile under it. So when you click all of these colored buttons, it'll cycle through those all of those different tile types there. So for example, you have like a yellow button with like a lava space below it. You click the yellow button and it'll cycle between being land, lava, and water, or something like that. Also, we have a gray one here, which was just used for general purpose, either clicking the button down once and it activates something, or clicking it to activate something over and over. And then we have the teleporters, which come in 3 different varieties here. This button, this was actually the original button that we were going to use for, actually this is basically these buttons, but for a block. Like you could only activate it by pushing a block on top of it. Didn't ever actually use those. These are used, or were used, as little, kind of like, if you imagine like redstone from Minecraft, kind of defining which buttons activate what and that sort of thing. And then this sprite down here was never used. So we have quite a few different entities we need to use here. Some of those are probably going to change over the course of this stream. There's quite a few things I'd like to add to this game that I never actually got around to in the other versions, and I think that this time around working in OpenTK, since it's going to be a lot more straightforward and I'm a lot more used to the framework here, we might have a chance to add all of those functionalities. So we're going to start. Let's do box gem. We'll leave most of the other ones. We can do some teleporters and an exit. I think that's the main ones we need right now, and we will add more later here. Add more support for the other ones. So we do box. We do teleport 1, teleport 2, teleport 3, and then we do gem. We do exit. That was basically all the ones I need right now. So we'll go ahead and get rid of that. So then we have a public, or actually we're going to make it private with a public accessor, public or private entity type. Entity type. And then a private point pushing enter there. System.drawing position. I think that's all we're going to have for now. We will probably add some more to this class later. Public entity type get return type. I forgot a semicolon there. Public point position get return position. Public entity serializable. We're going to have to take in an entity type and a point position. This dot type equals type. This dot, gosh, if I can type, position. There we are. That should be that for now. All right, let's go move back over to entity here. We're going to do a public entity. We're going to pass in an entity serializable. And this will be our constructor for making an actual entity out of a serializable entity. What is it now like here? Oh, there we are. We need a public point. Excuse me. Tile. What did I call the other one here? We have tile sprite sheet X. There we are. And then in the grid space, it is called sprite grid vector and sprite bid. Sprite grid pose. And this is going to be private, but we're going to make a public accessor, like I do quite often. Point sprite grid pose get return sprite grid pose. It's going to capitalize that, but I actually want to make that lowercase. There we are. And then we can actually just make these all inline as well, because if it's just a get accessor, I don't need to make it multi-line. Except for the position, because I think we're going to have some type of setting of the position. Unless I want to make those functions. I might make those functions. That'll be more readable. The reason that I don't want the outside sources to access the position directly, there's going to be a couple different things that I've ran into before with this game. I like to have kind of almost turn-based movement where you push over once and he moves from one grid space to the other, or she moves. The main character of this game is a princess. She moves from one grid space to the next, but she moves over maybe a series of like 16 frames or something like that, and while she's moving, other stuff still can happen. It's not like the whole game moves on the same time scale. So maybe a box is being pushed by some object as you're moving into the space that's being pushed into. You need to figure out what happens if she counts as already being in the place, or so basically the idea here is instead of allowing them to automatically set the position, we needed to do some stuff in order to keep track of where the player is technically and kind of where it's being drawn on screen and what stage it is of moving between the last position and the new position. That way we can kind of work out some of those bugs. I still haven't come up with anything that's super nice looking right now, or the way that I did it before. The minute you press an arrow key and you move to a new space, or something else pushes you into a new space, you technically count as already being at that new position, but it takes a few frames for the game to just show you moving from the last position to the new position. However, if something happens, like if you get pushed, if some block or something like that gets pushed into the position that you're moving into while you're still moving into it, you just kind of jump to the new position, or the position that you were moving to, and then get pushed by the block into the wherever you should be getting pushed. That's worked best, but it doesn't actually look all that great, because you could be moving halfway and then all of a sudden you'll snap to the next position and start moving in a different direction, which looks a little bit weird, but I haven't really come up with a good idea for how to solve that. So we're going to go ahead. We're going to do this. This dot position equals serializable dot position. This dot last position equals serializable dot position. This dot sprite grid pose equals. Well, we're gonna have to do a switch statement on this. All right, switch this. There are switch serializable dot type, not toString. Right, case entity type dot box break this dot sprite grid pose equals new point, and that's going to be 0, 0 because that's the position of the sprite in our tile sheet. We're going to do the same thing for all of the other entity types here. We have the exit, which is at 1, 2, 3, 4, 5, 6, 0. Yep, okay. And then we have gem, which is going to be at 3, 0. And then we have teleport 1, which is at 0, 1. And these are all going to be at, I've been using Sublime Text recently, and I keep forgetting the rectangle. Dang it, that's going to do that. Okay, and Sublime Text is a little bit different. Teleport 2 is going to be 1, 1. And this one's going to be 2, 1. Because they're all just in a line there. Teleport 3. Alright. And what else do we want here? We'll have a couple different flags here. We'll do private, bool, pushable, solid. I just put that in the other order just because if it's not solid, the pushable flag won't matter. That's all I really need. That's all that really carries over between all the objects. Basically, we just need a flag saying whether or not the object can be walked over. The solid flag there. If it is true, then we cannot walk through it. But if it's pushable, we can push it, or something can push it. So that's kind of our logic there. And we will set those for all the different types here. So solid, this dot solid equals true. Make them all solid for now, except that we don't actually want the teleports to be solid because the teleports you're supposed to be able to walk on top of. The gem, you also need to walk on top of it, and the exit also. So all of them are not solid except the box right now. However, most of the other things are solid. Then we need private bool alive. And this will track whether or not the item has been removed or killed or deleted or whatever you want to call it. Kind of varies on context there. This dot alive equals true. And then we already set solid and pushable. We need to make public accessors for those. Public push, bool, pushable, get return, pushable. And then solid. Solid. There we are. That should do for now, I think. I feel like there's one other thing that I wanted to add. It's got a position and a last position. Alright. Oh, that's what we need to do. In our entity serializable, or entity types here, we need to add the player entity, because the player is also an entity. And that's an important one. So we will add another line here. Oh, we didn't actually add pushable here. Okay, we'll add those here in a second. Player. And yeah, we'll just we'll leave the sprite grid pose as 0, 0 for now because we're actually going to be overloading the draw function with the player class. So it doesn't matter what this is. We'll make a note. And it's going to be solid. This dot pushable equals true. And these are all going to be false because they are not pushable, but the box is also pushable. Let's see here. Now, what we want to do, public virtual void update. Public virtual void raw. And these are going to be our update and draw functions. The update will do any of the base stuff that needs to be updated in any entity. And then we will overload both of those functions, or only the update function and all of the subsidiary classes that do stuff. Yeah, I think that's it for now. All right, so let's go ahead. What do we want to do here first? Well, we do need, actually, we need private float move %. And this will be a rounded float variable. Sorry, not rounded. It's going to be a floating point variable that holds a percentage between 0 and 1 of how far we are from the last position that we were at to the new position that we're moving to. If it's 1, that means that we are static or in the new position, and we don't really have to worry about the last position. So, public, we want to make a public access variable or float move %, get return move %, whoops, move %. Here we are. Represents value between 0 and 1 that represents the entity's progress in moving from last position to position. Alright, that's a lowercase there. Just so we can remember what that is. And then this dot move % equals 1. And then what we need to do is we'll make a public static. Static? No, we're going to make it a protected integer. Yeah, we're going to make a protected integer num steps. Let's do move steps. How many frames it takes to move from one block to another. This can be set, or this will be able to be set by each subsidiary class, but the default will say maybe 10 frames. This dot move steps is 10. And then what we do in our update, if move % is less than 1, then move % plus equals move steps, or actually let's do 1f divided by move steps, and we put the float there so that it doesn't round it to an integer. Move steps, if move % is greater than or equal to 1, move % equals 1. And then what we want to do also, we're going to have a public virtual void end move. And we don't really need any inputs because we have all the information that we need. And we will do end move here. So this will be kind of almost an event for the children class here, so that we can overload this function, and then whenever they finish a movement from one space to another, we can do some type of check or something with it. Really useful. One of the things we'll be doing a lot. And then what else we want here? Let's make a move function, public virtual void move to, or move, and we are going to make an enum called direction. This is one of the enums that I make a lot, but I still just forget to add it to kind of my standardized list here. I think part of the problem is I've been working in 2D and 3D at one time or another, and the idea of direction changes because you have up and down and three-dimensional stuff. So we're going to go over to, we're going to put it in structs, my structs, and we're going to collapse all of that because there's a ton of crap in here. All right, public enum direction, up, down, left, right. There we go. And then if, or we'll do a switch case, or switch on direction. We need a case direction dot up break. We'll do, how do we want to do this here? What we need is we need a reference or a way to access our grid of grid spaces in the game client. And I'm not sure how I want to do that yet. For now, what we'll do is we'll do, yeah, we're going to do position. We're just going to use this switch statement in here. Hold on just a second. Position equals position. Well, we do a new point. New point position dot x position dot y. And since I'm going to copy this, I'm going to just leave it like that for now. Copy this 3 times real fast. Down, left, right, and we will go -1, +1. Why do I keep putting semicolons on the end of my case statements? -1, +1. It doesn't like me setting position. That's why I keep not hitting the shift. That is my problem. All right. There we are. And then what we'll do is we'll do this dot last position equals position. And then we'll update that position depending on the direction that was passed in. And then what we can do, well, actually, we can just do it here. This dot move percent equals 0. This dot, I think that's all we need to do for now. So we will set the last position to be the position that we're at now because we're moving to a new space. And do we want to check? Okay, we also need to do something like this. Public virtual void can move direction. And this is going to be a function that we can overload that'll check in a direction and return whether or not the entity can move in that direction. This will be used when we are doing keyboard input on the player. We can check to see if he can actually move there before calling the move function. Or it can be used when maybe a box is pushing the player or another object. Basically what we'll do is we'll just do all the logic that needs to happen. For example, if the object is solid and non-pushable, return false. If there's an object in the way, then we return false. If there is a tile or a solid grid space in the way, we'll return false. There's a little more stuff that we have to do in crates or like boxes because if a box, or actually sorry, with pushers, the grid space that pushes stuff needs to be able to push multiple entities that are in a row. And we need to be able to find how many entities it can push. So we'll get to that eventually. For now, we're just going to do, if pushable, if not solid, well, no, let's just do pushable. Pushable, or if it's not pushable, we'll return false. And this needs to be a Boolean function. And then, let's see here. I think that's all we're gonna do for now, essentially. Save that. End move doesn't do anything in the base class. Update seems to be working correctly. We will return true otherwise here. And then in our draw function, we need to do sprite batch, or actually let's do this. Vector2, we have not included OpenDK yet in this file. Source pose equals new vector2 this dot sprite grid pose dot x times 10f, or actually 1 divided by 1f divided by 10, because I believe there are 10 in this yet again. 3, 4, 5, 6, 7, 8, 9, 10. Yes, there's 10 tiles across and 10 tiles down. This actually, I think, if I remember right, is what I wanted to change about the main game. I wanted to make it modular so that you can increase the grid space size as well as the tile sheet size. And we will get around to that eventually, probably not right now because I want to get some stuff output so that we can get some type of working product by the end of this video. So then what we do, hold on, if I remember right, I think the sprite batch class actually takes pixel values and not just percentages, which means that I needed to change this. Yeah, so for now we will just do times 16 because each tile is 16 pixels by 16 pixels. So, and then we do sprite batch dot draw, and we'll do, we need to load in that texture, and that texture is going to be a public static texture. Static entity sprite sheet, oops, texture 2D, entity sprite sheet, and then in the game client, in the load content, we need to do entity sprite sheet equals content pipe. The load, and I think it's probably called entity sheet, entities sheet, sheet.png true so that it's pixelated. Back to our entity class here. Then we can draw the entity sprite sheet, and we can draw it at, and we're going to have to be passed in a vector2 position, vector2 size, position, size, 0f, color.white, vector2.0, 0f, and then new rectangle f. Can I do, okay, no, it just takes that. Okay, so that we do sprite, what did I call it here? I can't see. Source pose, source pose.x, source pose.y, 16, 16. Here we are. And now what we can do in the game client here, we will have a list of entities. And this list will be instantiated in the constructor. Actually, no, it's going to be instantiated in the go-to level. Did I? Oh, it's just because it's closed. This dot entities equals new. We're actually going to move this down to the bottom of the function here. I'm going to do for int I equals 0, I is less than loaded level dot entities. It is not in the loaded level at the moment. We need to do that. So private entity entity serializable, that is. Entities. And then in this, we need to do this dot entities equals, and we need to do is loaded level dot entities dot copy. And it's going to be copy 2, and it's going to take a ref here, a reference. Dot copy 2. We're going to copy to this dot entities 0. Does it need a reference? Gosh dang it. No, what does it want? This dot entities equals new entity serializable loaded level dot entities dot length. Basically, it just wants this array to be initialized before I actually copy it to it, so it just needs to be the right size. That's done there. And then the level here, we need to do the same thing, except for that entities equals new entity serializable. And we will actually, in a basic level with 20 by 20, we're going to make new entity serializable entity type dot exit, and then new point, and we're going to use system.drawing so we don't have that in there. There we are. New point. We will do like 10, 10. That's all we need there. Need to close that. There we are. So the default level will have an exit in the middle-ish of the room. Now, in our game client, we can do load level dot entities. We need to make a public accessor for it. Yeah. Public entity type. Sorry, entity serializable. Entities. Get return entities. And then load level dot entities dot length I plus plus. And we're going to do this entities dot add new entity, and we're going to pass it in the entity serializable I. There we go. That should create those entities there. Then we need to go loop through all the entities here. For int I equals 0, I is less than entities dot count I plus plus. Entities I dot update. And we want to do nearly the same thing for draw. Except that we need to pass it some stuff. Entities. We'll do new vector 2 here. New vector 2 entities I dot position dot x entities I dot position dot y, and it's going to be drawn times vector 2 16 16 because that's the size of our grid. We need to tell it where to draw itself, because later on we might want to be able to manipulate the position of where everything's drawn from the game one here. No. Why are you not? I just need to do new vector 2. That's the problem. What else do I need here? New vector 2 16 by 16. Because we're just going to be drawing at the same thing there. Alright, and now just to test this, we are going to if my dot key down keys dot shift, I'm gonna make it so that if we are clicking with the left shift held down, it will add entities instead of replacing the tiles like we had before. We won't do anything there for right now because I don't have all that much time, but entities.add new entity serializable entity type dot box. We will add a box and we will add it at the mouse point. There we are. So I want to say this will work, but I have not ran it in a while, so we might get something wrong here. Yep, where did I mess up? No reference exception, entities, lower level entities that link, break. Because we're loading a level that doesn't actually have entities in it, we just need to delete the old saved level. So bin debug, and not in content, save.level, no longer saved. Let's try that again. There we are. And you see that we have our exit added there. If we hold shift, yay. And I'm pretty sure I just added like a bajillion boxes there because I think, well, I know that you can add multiple entities on one space. It's not getting rid of the last one, so I'm pretty sure lots of these have multiple entities on one grid space. So we'll have to do some checks there. For now, I think this is where we're going to have to leave it. It's a little bit unfinished, shall I say, but we'll get to some more pretty soon here, probably the next couple days. Thanks for watching, guys. Have a good day. I'll see you later. Bye.